Our next speaker is Jaya Kawale. She's with Tubi, and she's going to talk about leveraging deep learning and LLMs for content metadata. And I asked her for what's the term that really represents your essence? Like, who are you? And she said, eternal learner. Welcome to the stage.
Thank you. Hello, everyone. I'm so excited to be here. This is my 4th time, I think. And every time I come here, I'm really energized by this conference. I think the way you organize it is so good. So today, I want to talk about something that we've been working on at Tubi, something really cool, and of course, it includes LLMs. So before I go ahead, let me just tell you what to expect in the talk. So at the very beginning, I'll tell you how machine learning can help streaming services like Tubi. And in the part 2, we'll talk about a case study of content metadata leveraging LLMs. Okay. If you have not heard of Tubi, please do check out. It is a free streaming service in which you can watch free movies, TVs, news, and sports. And over the past few years, we have grown a lot. We have more than 64 million monthly active users. We are available across several countries, including US, Canada, Mexico, and Latin America. And very slowly, we have grown to be one of the most loved AVOD streaming services, which is advertiser-based video on-demand streaming service. In the Super Bowl, we had an ad which made us viral as well, and we have a lot of people checking us out, so please do check out if you haven't already. So how can machine learning help streaming services like Tubi? So at the core of streaming services like Tubi are 3 important pillars. The first and the very important pillar is the audience or the users. The second and another really equally important pillar is the content, or the content that is available in the form of movies and TV series. And the third and an equally important pillar is the ads, because ads is our bread and butter and it helps us generate the revenue for the streaming service. So machine learning plays a very fundamental role in helping the 3 different pillars. So for the audience part, machine learning can help with content recommendations. So machine learning can help surface the titles that people would love to watch. On the content side, machine learning can help with understanding of the content better, help understand what resonates with the audience and what does not. And on the ad tech side as well, there is so much that machine learning can do. So these 3 pillars are interconnected, and machine learning operates in a very fundamental way. So bigger audience leads to more ads watched by Tubi, more ads watched by people, and leads to more revenue for Tubi. More revenue from ads means we have the capability to buy more shows, and more and better shows means that we can attract more audience. So let's talk about the very first pillar, which is recommendations or personalization. And on the Tubi homepage, our goal is to have machine learning power each and every pixel that you see on the homepage. So for example, machine learning helps with the ranking of the content that you see on the homepage. Machine learning helps with the ranking of the containers or the rows that you see on the homepage, helps with the ranking of the images for a title, helps with the ranking of search results, autoplay, generation of the containers themselves, and also with the cold starting of titles. So I'm very proud to say that we have 70+ models on the machine learning side, which helps generate this this homepage. The content and containers ranking are based upon various features, mostly relying upon the interaction data, but also leveraging the rich information that we have about every title. The ranking is mostly based upon gradient-boosted decision trees, and slowly we have seen a lot of success with deep learning, even on the ranking side. And the retrieval is based upon embeddings. As you can imagine, we also rely on like variety of various different embeddings, like two-tower, natural language processing-based embeddings, and whatnot. So for the ad side, the machine learning, just giving you a quick overview, machine learning can help us understand the ads better. For example, machine learning can help us understand what an ad is about. An ad within Tubi is basically a video. Machine learning can help us understand what ad resonates very well with an audience, what audience segment would prefer what ads, and not just that, it can also help us forecast ad opportunities and also help us place the ad better within the video of Tubi. So today's talk is going to focus mostly on the content understanding side. This content is the third and an equally important pillar within Tubi. And so with every piece of title that is available on Tubi, there is a lot of information that is available along with that. We have a variety of information that can be obtained from various different sources. For example, IMDb, Rotten Tomatoes, Grace Notes, Wikipedia. Then we also have subtitles, we have transcripts. We can also use video analytics to get rich textual information about a content. So what information do we know about a title? So we know a lot of information about a title. We have partnership with various like these movie databases, and we can get information like the ratings, the box office information, the plot synopsis, the cast, metadata, reviews, etc. And how can all this information help? So all this information about the content can help us understand the preferences of our users better. They can, in a way, help us improve the recommendations themselves. They can also help us influence the buying decisions of the content themselves. Because once we understand what resonates very well with an audience, we can go ahead and double down on that kind of content. Or once we understand what kind of content is not very well represented at Tubi, that we can try to buy that content and help build an audience around that. It can help improve the cold starting behavior. When new titles come in on Tubi, we have very little information about the title in the sense that we have very little information how the title will be perceived by the audience. But once we have the rich textual information available about a title, we can use that to cold start titles better. It can also help us with the categorization of the content itself. So what are some of the tasks that can be classified as content understanding? There can be a lot of multitude of different tasks, but it can start with simple keyword search, classification of reviews into doing some kind of sentiment analysis, doing some topic extraction, generation of embeddings, to more and more fancier stuff like what we are seeing right now in the era of LLMs, like question answering itself. So one thing I think everybody probably already knows is that content understanding is very hard. And the reason why it is very hard is because there is ambiguity in representation and learning when we are talking about a natural language. Here is a quick example. If you are searching for the title Kids Horror, I'm sure you're not looking for titles which make kids horrified, but you're looking for titles which are kids-friendly and which you can show to your kids, which are good horror movies. So there is a lot of ambiguity that a machine learning model needs to understand, and that's why content understanding is hard. So at Tubi, we have built a Spock platform which helps us with the understanding of the content. So the platform helps with the ingestion of the data. There is a lot of pre-processing that needs to be done before any of the content can go into these models, because it's always garbage in, garbage out, especially when it comes to user-generated content like reviews. So the platform helps us do that. We generate a variety of embeddings that help our various different use cases, and it also helps us assess the quality of the embeddings themselves. So here is a quick overview. What we do is that we have the Spock platform, which ingests a lot of first and third party data. And the byproducts of this Spock platform are not just embeddings, but also models themselves, which can help power various use cases like cold starting, content value assessment, tiering of the titles, search, and whatnot. So let's focus on the second part of the talk, I think, which is what you are also very interested in, which is how can we use LLMs for content metadata. So in this talk, I'm going to focus on one particular type of content metadata, which is the film genre itself. All of you are already aware of film genre. And borrowing the definition of a film genre from Wikipedia, a film genre is basically a motion picture category based on similarities either in the narrative elements, aesthetic approach, or emotional response to a film. And of course, the subject matter. So from this definition, three things are very clear. First of all, the genre assignment is a subjective endeavor. Movies have characteristics of more than one. And the space of genre should be continuous and should not be discrete. So let's take a deeper look at this. So where do we get, first of all, the genre information from? So there are various different websites, like we mentioned already, and you can get genre information from these various websites. So you will say, then what is the problem? You can just use what you get from IMDb and you're good to go. So here is the problem. First of all, there is a lack of a universal definition of a genre. What should be a genre? Broader genres like romance, action, comedy are widely accepted by everyone. But what about niche genres? Is sports a genre? Is Western a genre? What about Bollywood? Do you think it should be a genre? What about Hollywood then? If Bollywood is a genre, should Hollywood also be a genre? So there is no consensus on genre categorization from the various different sources. The labels themselves can be noisy, inconsistent, and subject to the personal judgment of the annotators. Another thing is that the coverage of the less common labels tends to be very limited. So this creates a problem. So another thing is that there are certain genres like rom-com. I think we all know about rom-com. Rom-com is romantic comedy, but which are a combination of two genres. Now this complicates categorization, and it also introduces ambiguity. So movies can belong to multiple genres, and the assignment of genres can be subjective. Another thing is that, here is an important point. The genre labels do not capture the degree of intensity of the genre within the title itself. So taking an example of the movie Jurassic Park, so Jurassic Park classified as science fiction and adventure, totally. But it also has elements of horror and thriller. So what should you classify it as? Should it be horror? How much thriller? And so on. One more point I want to mention is that the movies within this same genre can exhibit substantial differences. Look at these two movies. These two are my really favorite movies, Gladiator and Die Hard. Both of them are categorized as action, but both of them are actually a world apart, like literally ages apart. One is like from an olden times and another one is a very modern movie. So what we did was, at a very first step, what we did was we just tried to understand how are these labels represented within the movies that we have already. So a couple of things stood out. First of all, not all genres are represented equally. As you can imagine, there are some genres which are much more represented as compared to others. Drama and comedy occur much more as compared to something else. And there are many cases in which the genres co-occur as well, which is very good because which tells us that there is a possibility of creation of this particular subgenre, which is a combination of two genres. When the genres are similar, there is a confusion, and when they differ, there is an opportunity for a subgenre. So here is what we did. So as a very first step, what we did was we thought that this genre itself should be more of a continuum. And what we want to do is define what should be an ideal genre. So an ideal genre, according to us, should be a spectrum. So that's why we call it as a genre spectrum. And the representation should be in a continuous latent space. It cannot be discrete, it needs to be continuous. So what we want to achieve is that movies that are labeled with the same genre should be embedded closely together and vice versa. So how can this concept of genre spectrum be materialized? So there are a couple of things that we want to do. So first, the quality of the genre spectrum embedding should be high if the genres are well separable. Definitely we want that. And a simple genre prediction model, what we saw, was giving us like really good performance. So let's take a deeper look at that. So this is also based upon a paper which is appearing in Rexus 2023, which is in Singapore this year. And the idea behind the genre spectrum embedding is to have like a deep learning model help us take the rich textual information and get to the spectrum of genre that represents the spectrum for each and every title. So the input to the deep learning model is the rich textual information, and the prediction needs to be like a multi-class, multi-label problem. There are two key components of this deep learning model. The first component, or the transformation function, transforms the input vector into a latent space, which we call as the genre spectrum space. The second component takes the spectrum space and does the prediction into the multiple labels. And of course, there are a lot of nitty-gritty details in how this deep learning model is set up and how we borrowed a lot of, like goodies from the deep learning world on data augmentation and whatnot to handle the noisy labels, which you can find in the paper. But at a very high level, what I want to mention is that we have a deep learning model which helps us take this rich textual information into the spectrum of genres that a title should have. Diving just a little bit deeper, as you can imagine, if it is a multi-class, multi-label problem, the loss function needs to be some kind of a binary cross-entropy loss, and the deep learning model is just given the input, we try to learn the output with the help of this loss function. So how do we handle the textual information? We, like I said, we have a rich variety of the textual information. There are like a variety of different things that we can do. And we can do things as simple as, doc2vec kind of a model. And all this, the creation of this genre spectrum embedding actually started like way before the LLM era. And so we started with this, very simple model, doc2vec. Actually, it's a very powerful model in my opinion. And then, of course, we saw the power in the transformer models and started with BERT, etc. And we've also tried our hands with LLM and GPT. So the textual information is mapped into the embeddings that can be obtained in a variety of different ways. And then finally, we get the genre spectrum embedding, which can be used as a good representation for a title. And over here, what we want to see is how can we evaluate the quality of the embeddings themselves. This is a really, really important question in the embedding world, and we generally do not have a really good answer to it on what constitutes a very good embedding and what constitutes a bad embedding. So what we did was we looked at two surrogate tasks that help us, two important points that help us identify what constitutes a good embedding. So first of all, we want to be able to classify the genres better. That was our first thing. And the second thing that we want to do is that the nearest neighbors in the latent embedding space should be a good representation, should be good enough. The reason why we want to do that is because most of the retrieval these days is based upon the nearest neighbor space. And if we want the journal spectrum embedding to be like a good representation for the retrieval space, then we want to be making sure that the nearest neighbors are good enough. And more details of the results and evaluation are in the paper, but at a very high level, what we found that as we go from doc2vec to, like the transformer GPT kind of models, we were seeing increase in performances as well. Not very surprising, these large language models definitely have a lot of power. And what we thought was, can these LLMs help us even better? Like utilizing the embeddings is one thing, but can we go a step ahead? And can we help generate a categorization of the titles themselves using these large language models? And yes, we were able to play our hands at something, and what we call as micro-genres, what we did was some kind of a few shot learning process in which you engineer the prompt appropriately, and what you're able to get is a rich information about a title itself, along with a confidence score on how much this particular micro-genre is a representation for this title. This is still ongoing work, but we are seeing really good value with using LLMs. And what we think is that content metadata, the understanding of the content metadata can largely be helpful with the help of LLMs, because the road ahead is even more promising. We can do fine tuning, we can look at various different use cases, and maybe the different use cases need the model to be fine tuned for that particular subcase. For example, the creation of the categories or the containers themselves, cold starting of titles, content evaluation, and many more of these use cases probably need a fine-tuning of the LLM catered to that particular use case. Another thought at our mind is, can we have like domain-specific LLMs? Possibly. But even before we go there, I would definitely say that there is a lot of value in few-shot learning itself, which needs to be utilized and leveraged thoroughly before we go into any of the fine-tuning and domain-specific LLMs. So just to conclude my talk, content understanding can be greatly beneficial, can benefit a lot from the era of LLMs, and there is a lot of valuable information in LLMs, and there is a lot we can do beyond embeddings, like there's few-shot learning, prompts, fine-tuning, and domain-specific LLMs, and whatnot. So definitely, just a 1-minute pitch. Join us if you want to help build the next generation of models. We are hiring in these times as well. We are hiring, which speaks a lot about us as a company. And feel free to send me an email if you're interested. Thank you.
Do we have time for one question, if you don't mind entertaining it? Okay, cool. The lucky winner right here in the middle. Sorry, Matt. Here you go, sir.
Yeah, thank you for such a great talk. But I just wanted to ask, like, where does few-shot learning help in the entire pipeline? Like, I just think that fine-tuning is a more better thing than few-shot learning. I think few-shot learning is a bit more underrated, but where does it like really help?
Yeah, I will say that few-shot learning is very underrated. Like, I will definitely say that try few-shot learning even before you go into fine-tuning or touching the model at all. There is so much value because these large language models are trained out of so much of data. They know so much about, the world at large, and maybe they can help solve your particular use case as well. In our case, the movie world. And fine-tuning is definitely helpful when you have a very, like domain-specific problem. But before that, I will say just exhaust the few-shot learning.
Excellent. Thank you so much.